So welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 6, part B from the October 2024 Mechanics M1 paper. This is from the Edexcel International A-Level. Part A was about statics. Part B is about dynamics. So it says the horizontal force is now removed. So there was a horizontal force that was keeping this in equilibrium. It's now removed and P starts to slide down the slope. Okay, so the reason I'm saving this as a separate video because it's like a separate chapter or topic, dynamics, not statics anymore. So P starts to slide down the slope. So it's going to accelerate this way. All right. In the first t seconds, after P is released from rest, P slides 1.5 meters down the slope. Let's say that's 1.5 meters. It slid down the slope. Okay, so that's how far it slid down the slope. Find the value of t. Okay, so we're going to find the time it takes to slide 1.5 meters down the slope. So what we got to understand here is now we have a situation where the horizontal force has been removed. That was there before. So we have its weight acting directly vertically downwards. Vertical. It's a bit lopsided. Okay. You have the reaction force acting between the plane and the object, which is always perpendicular to the surface of the object. So this was, his mass was 5. So this is 5g newtons. This is the reaction force. And the reaction force won't be the same as before because there's no horizontal force now, which is trying to, or affecting the reaction force. And we're going to have, because it's sliding down the plane and we have a rough plane, we're going to have frictional force acting up, and that frictional force will be equal to F max. It will be equal to F max. All right. Because it's sliding down, friction is going to act up. So now, we're going to resolve the force of the weight. We're going to resolve the weight parallel and perpendicular to the plane. Okay, so as we know, this angle is alpha from similarity, okay, as we discussed in a few videos already. And we know that the force acting the weight resolved in the direction perpendicular to the plane is going to be 5g times cosine alpha, and in the direction which is parallel to the plane, it's going to be basically 5g times sine alpha. Going into the angle, going away from the angle. So that's 5g times sine alpha. Okay, so now we want to find the acceleration. So the resultant force, if we take this direction as positive, is 5 times g sine alpha, okay, minus, and you're going to have only force acting in that direction is F max, is equal to the mass, which is 5, times the acceleration, which is a. So I need to find what F max is, and we know F max is equal to mu r. So let's resolve the forces perpendicular to the plane. We have r is equal to 5g cosine alpha. And so F max is going to be mu times r, which is a quarter times 5g cosine alpha. Let's actually calculate what this is. Cosine alpha is 4/5. So a quarter times 5 times 4/5. Okay, the 4/5, but I'll just write it out so you can see what's going on. A quarter times 5g times 4/5. These cancel out. So you're left with g. So we can say that F max is equal to g. Okay, so that's F max. So now we can say 5 times g sine alpha, and remember sine alpha is 3/5. So you're going to have 5g times 3/5 minus F max, which is g, is equal to 5a. So that cancels with that. So you got 3g minus 2, which is 2g equals 5a. So a is equal to 2/5 of g. Okay, that is the acceleration going down the plane. Okay, 2/5 of g. I'll leave it in that form for now. And we want to find now the value of t, the time it takes to slide 1.5 meters down the plane. So let's now use our SUVAT values. Okay, we have S, U, V, A, and T. Okay, so the SUVAT values here. S is 1.5. I'm taking down the plane as positive because it's moving down the plane. U is 0 because it was released from rest. So initial speed was 0. Okay, and V is equal to, do we have to find that? We don't. No. So we just call it V. A is equal to 2/5 g. Okay, that's acceleration. It's 2/5 g. Okay. Do we need anything else? Nope. Okay, so there we have all the information we need. We want to find the time. Okay, we want to find the time. So we have S, U, A, and T. Okay, we don't know what V is. We know U is 0. We know S is 1.5. We know A is 2/5 g. We want to find T. So we can think of S equals UT plus a half AT squared. So you got 1.5 equals 0 times T plus a half times, you're going to have A, which is 2/5 g times T squared. Okay, so that's 2/5 g, so that's 1/5 g at the end. Half times 2/5 is 1/5. Okay, so we have now 1.5 is equal to, and that's going to be 1/5 of g T squared. Okay, so 1.5 is the same as 3/2. So let me write it as a fraction to make life slightly less complicated. So that's 3/2. So what we can do next is we can solve this equation for t by basically multiplying both sides by 5. So you have 15 over 2g t squared. That is, 15 over 2g. One second, let me do it the other way around. So I'm going to multiply both sides by 5, so that's 15. And I'm going to divide both sides by g. So it's 15 over 2g is equal to t squared. So t is equal to the square root of all of that, 15 over 2g. Okay. So that's going to find us our time. So let's work out what it gives us. We're going to have the square root of 15 over 2 times 9.8. Okay, and that gives us 0.874 seconds. That's 0.874 seconds. That's the answer, okay, to this question 6 part B. So this follows on from 6 part A, but I've saved them as separate videos because this is to do with dynamics and A was to do with statics and limiting equilibrium. So that sums up this question. I hope it was clear. Other questions from this particular paper or this particular exam, October 2024 M1, you find it in the link over here at the top of the screen. Other questions you might have, or any if you want to see other playlists dealing with the same kind of issues of connected particles, you can click on the list down there. You can subscribe to the channel by clicking on the link over here, and at the top you can watch a video which tells you how to use my channel effectively. Thank you for watching, and see you soon.